Let's look in this video at how to recognize a difference of squares when you're asked to factor it. In the last video we covered how to recognize a PST. So a difference of squares is exactly like it sounds. It's a difference, which means subtraction, of two things that have a perfect square root. And if we are asked to factor one of these, we want to recognize it because it allows us to get back to the answer very quickly when that pattern is present. So let's begin with factor this. Let's do x squared minus 81. So again, in my factoring toolkit, I would always first ask the question of, is there a greatest common factor? And in this case, the answer is no, because the numerical part of this term is a 1, which is a very small term, and this doesn't have any x's in it, so there's no GCF. We don't have 4 terms present. In fact, we don't even have 3 terms present. So we can't do our little PST test, and we're not going to use our thinking chart to come up with two numbers that multiply to give A times C and add to give B. We are now into a new pathway of we only have 2 terms present. Okay, so this is where we want to recognize is the difference of squares. So I can see that the differences there. Are these both squares? Well, very simply put, the answer is yes, they are. We can have the square root of the first one, which is x, and we can have the square root of the second one, and I'm going to leave the difference out because I'm going to leave that as a separate criteria for this test. The difference has always been accounted for, so now I'm just going to look at these. So the square root of 81 can be plus or minus 9. So how are we going to account for that when we're factoring a difference of squares? Well, easy enough. We're actually going to account for it in both cases because we know that a difference of squares is the product of both the positive root and the negative root of that second term. So my final answer would be simply x plus 9 and x minus 9, and it doesn't matter what order they go in. But there you go, and that would be it. And if you FOIL this out in your head, you'll discover that the outside and the inside terms do cancel out perfectly to just leave the products of firsts being multiplied by each other and lasts being multiplied by each other. So factoring a difference of squares is pretty freaking awesome. Okay, let's take a look at another example. Let's do 4x squared minus 49. First of all, is there a greatest common factor? Well, out of 4, I can either take out 2 or 4, but neither of those are factor of 49. I don't have 4 terms present. I don't have 3 terms present. I have 2 terms present. Let's see if this is a difference of squares. I see the difference, so again, let's apply this 3-point test. Difference being the first point. Does this have a square root? Yes, its square root is 2x. Does 49 have a square root? Yes, its square root is plus or minus 7. So, once I've identified what those square roots are of the first and last terms, I can go straight to the factored answer. The factored answer would be 2x times itself at the beginning of both binomials, and let's allow one of the 7's to be positive and one of them to be negative in order for us to get the desired result. And there you have it. That's how we can factor that difference of squares. Let's do one more example, and I'm going to intentionally change it a little bit from the one that's in your note. What's in your note says 15x squared plus, actually, I'm going to leave it the way it is. It's all good. I'll add in an extra one at the end. Plus 24y squared. All right, if you're asked to factor this, again, you're going to follow the same steps. Is there a greatest common factor? Well, they both have a factor of 3 that we can take out, so we should take it out. There you go. Done. What's left to factor does not consist of 4 terms or even 3 terms. It consists of 2 terms. So we will apply then the difference of squares test to see if we can factor it further. Well, the very first step in the difference of squares test is to look at, is there a difference? And the answer is no. So this automatically fails the difference of squares test, which means I've factored it as far as I possibly can. That's it. Okay, and we're done. The last example that I'd like to do with you looks like this. Let's do okay. And if you're asked to factor this, what are you going to do? Again, you're going to go through your checklist. Is there a greatest common factor? Well, I can take 2 or 4 out of here, and I can take 2 or 4 out of here. I'm going to choose the larger of the two because that would make it the greatest common factor. So let's take the 4 out. All right. What's left to factor does not consist of 4 terms or 3 terms. It consists of 2 terms. So let's apply the PST test to it, or sorry, the difference of squares test to it. There's the difference, so that's good. And then let's see, does this first term have a perfect square? Yes, it does. It's x squared. I'm just going to write it off to the side. Does 9y squared have a perfect square? And again, remember, I'm not including the negative because that's one of the criteria for the 3-point test. The answer is yes. It could be plus or minus 3y. Okay, so let's write that out. So we have 4 times, I'm going to write x squared times itself at the beginning of both binomials. And I'm going to write plus 3y in this one and minus 3y in this one. Now something else to be mindful of is that even if I finished here, there can be occasions where, especially this term right here, might still be able to be factored. Notice how it kind of almost looks like a difference of squares. There's the difference. This has a square root, but in this example, this does not. But you might come across a scenario where you could take this even further and treat it as another difference of squares. So just be mindful of watching for that as you go through your practice. Okay, that's it for the lessons of this unit. The final video that I'll post for you is a consolidation or a flow chart that I'm going to create for you to show you this in maybe just a different visual way that helps you piece together all of the tools in your factoring toolkit.